Good day, I'm Rama Adris and I am discussing with you the kinetic energy of rigid body in plane motion. So before we start, let us first differentiate kinetic energy and potential energy. So we have here kinetic energy is defined as the energy of mass in motion, while the potential energy represents the energy that is stored up due to the position or stresses in the body. So let us first consider this figure wherein this rigid body of mass m in plane motion consists of individual particles I. The kinetic energy of the body can then be expressed as 1 half mv negative squared plus 1 half summation change in mi vi squared. It is now then equal to 1 half mv negative squared plus 1 half of the summation ri squared change in mi multiplied to omega squared. We can then now say that the kinetic energy is the 1 half of mv negative squared plus 1 half I omega squared. So here in this 1 half mv negative squared, ito yung siya yung translational kinetic energy, while this 1 half I omega squared is yan siya yung sa rotational kinetic energy, which is I'll further discuss it mamaya. Kinetic energy of a rigid body can then be separated into the kinetic energy associated with the motion of the mass center G, and the other one is for translation and rotation. We have here the kinetic energy associated with the rotation of the body about G. We have here the formula, yung kinetic energy is equal to 1 half mv negative squared plus 1 half I omega squared. Ito na yun siya yung combination ng translation and rotational kinetic energy. Consider a rigid body rotating about a fixed axis through O. We can now say that the kinetic energy is equal to 1 half summation of change in mi vi squared is equal then to 1 half summation change mi times ri omega squared. Gi-substitute lang yung value ng vi squared into ri omega squared. And now it is then equal to 1 half summation ri squared change in mi omega squared. So, kapag sa rotation ng sa fixed axis through O na siya, we can now then use this formula. Ito na siya. Kinetic energy is equal to 1 half of the mass inertia of O multiplied to omega squared, which is equivalent siya sa formula kanina nung translation and rotation na 1 half mv negative squared plus 1 half I omega squared. Let us consider this rigid body wherein, as you can see, yung rigid body natin is nag-rotate siya about a fixed axis through O. Remember to only use yung formula kanina na 1 half I O omega squared when O is a fixed axis of rotation. The kinetic energy of a moving object is equal to 1 half mv squared, while sa kinetic energy of a rotating object, we have here 1 half multiplied to its mass moment of inertia and angular velocity squared. So I have some simple example here for translation and kinetic energy of a body, wherein, as you can see, ang ball natin is linear lang yung motion niya. Given here, we have 1 kilogram and 2 meter per second. So, substituting the formula, we can now come up with the kinetic energy equivalent to 2 joules. For the rotational kinetic energy of a body, as you can see, yung ball natin is nag-rotate na siya. We have here given 1 kilogram, 2 rad per second, and K is equal to 0.17 meters. So, ang K na yan siya yung radius of gyration. So, substituting the formula, we have here K is equal to 1 half I omega squared is equal to 1 half 1 kilogram multiplied to 0.17 meter squared times 2 rad per second squared is equal to 0.058 kilogram times meter squared meters and all over squared second is equal to 0.058 nm, or kinetic energy is equal to 0.058 joules.